Okay, guys, so welcome on the session that it's called Adventures in Underland, and it is what your system stores on the disk without telling you. Well, first of all, before we're gonna get to the brain frying stuff, as you see this morning, I'm serious about that, yeah? I'm very serious about that. So if you don't like your brain to be fried, make sure you're gonna sip coffee or something like that. Yes, take some chocolate, because what we're gonna talk about, it's gonna be a lot of cryptography pretty much today. So let's move along. My name is Paula J, and what I'm doing for a living, it's security. I am the person who established a company that's called Secure. And pretty much it was 8 years ago. And for now, I'm doing all the same stuff. I'm a security researcher, security passionate, playing with the different kinds of customers all around, delivering different kinds of security projects, especially the penetration tests. This is purely my hobby. I do love security very much, and I do have access to the source code of Windows, even though for that kind of stuff, source code didn't help. And the reason why, you're going to see, there's a lot of research that has been done from this session, and I'm super, super happy to show this to you today, because one of the things that we're going to touch, it's going to be the world premiere of the new Mimikatz with the new functionality that is pretty much impacting the security of infrastructure. So, couple of words regarding the session. Where does it come from? So it comes from the one simple thing. Whenever we do have operating system and it's pretty much in operation, it saves different kinds of information to our disk. Sometimes we are wondering, like, is there a chance that there is our password being stored on the disk? Answer is yes, there is actually. I can tell you that right now. My question is, how can we grab it? Where do we grab it from? What kind of encryption levels do we use? Before we proceed, I got one thing for you, and that is the tools. Because nobody who ever comes to my sessions is leaving with the empty hands. Have a look at the tools and then download them, make sure that you're going to test them out. What is the small disclaimer though, is that after this conference, I am putting all of the tools that I've been using on all of my sessions within this week. Couple of tools, they do have a raccoon icon. Please do not run the raccoon icon in the production environment, okay? As you know, raccoons, they can get quite nasty, and it's exactly the same with the tools, yeah? Okay, this is so you have been warned, yes? Next thing is that we're gonna use, of course, Mimikatz, and volatility is also additional tool that you can use on the top of what we are describing. And whenever we are thinking about that toolkit, just go over there and pretty much have a look. Whenever it's about disk analysis, the story is actually very simple. There is a lot of information being stored on the disk. We obviously see all those different kinds of files, but is there any kind of information that we can grab out of the disk that is, in a way, hidden? Answer is, of course, there is, and we kind of expect that. Question is how we are able to leverage that information and get access to this information. As you see on this picture, a couple of animals can hide quite well, and it definitely is applicable to the files in the operating system. The agenda for our session is divided into two parts. One is the data chunks. We're going to be analyzing different kinds of data chunks in the operating system, having a look over here, over there, over here, and finding out what kind of information we can get from the disk. This session is purely based on the knowledge. So if you will not find me entertaining, apologies. Because this brain frying at the very beginning, it really makes us focus. So whenever we are thinking, of course, about the system scenarios, I would like to show you the way how we are able to steal the user's secrets from the data protection API. So pretty much, we're going to be hacking the user's store, so-called, so protected storage, and we will discuss, is it secure nowadays, or maybe it's not. Whenever we are thinking, of course, about different kinds of scenarios, question is, what kind of information we store in the operating system in the cache. And it's kind of funny how we are able to analyze this information, because what is cache? Cache is something that is pretty much safe on the disk because application does this. How it was constructed, how it looks like, it's purely designed by the developer. There are different kinds of caches that we are using on the disk, written by different kinds of solutions in Microsoft. And the sad part of it is that for every single cache thing, we need an additional separate tool to dig in and to exploit whatever is inside. The subject is quite difficult. As you see, we are having on this different kinds of leftovers. There is a very famous data.dat application that we can turn on a Windows server right now. But here comes the tiny question. If we've got a data.dat application and the disk is obviously saving space by managing the different kinds of chunks of data, the question is where those chunks of data are stored. And it's the more question to bring to the field. If you're going to delete this data, will the chunks be deleted too? And answer is, depends, under different conditions. I want to show you everything. Another thing is obviously the log files, yes? But that's quite regular information. For example, one of the famous logs files, we've got the client-based servicing cbs.logs, where we can find the information about whenever we are installing, for example, Service Pack, that it failed, and a couple of other things. We've got also temporary internet files, where we are saving all the different kinds of information that we got from the internet, and different kinds of deletion techniques that are used against the drive so that we are able to recover our files even though we're going to delete them. Whenever we are thinking about all these kind of places where we can find the passwords and so on, there are plenty. One of the things, as we already know, is ntds.dist. I was showing this on the previous presentation, but we've got also a very serious file that is stored on the disk, that is the hyperfill.sys. Did you know that it contains all of the passwords that were used during the session, whole memory with the passwords being there in an encoded form though, but grabbable in a clear text, they are on the disk. Let's, of course, start the presentation and let's discuss all the stuff. cred.his is actually pretty interesting too. cred.his is a very special file that is within the user profile in the protect folder. So up data, you jump to roaming, Microsoft protect, and over there you find a very interesting file. It's called cred.hist. It's the history of all of our credentials that were ever used within this profile, encrypted with our keys. Can we get access to those? Of course we can. Yes, that's why we got this session. Whenever we are thinking about a simple demonstration from the beginning, let me show you actually something interesting. In the Internet Explorer, we've got this private mode. Yes? What is pretty interesting, I mean, private mode, probably you were always wondering, like, what kind of usage has this? And I'm sure, you know, you're thinking about the same thing as I am thinking right now. A question is, do we really, I'm going to start the process monitor underneath, do we really keep the information secret? Have a look. In the process monitor, I have set up the filter, which is to explore.exe, that's the process name, and I'm going to monitor the category right. So what I want to show you, and okay, that's the filter. Right now, we've got our process monitor running with a pretty rules. So what I'm going to do, I'm going to simply speaking, I'm going to just type my surname over here. What is obviously happening is that information, whatever we are browsing, there is some presentation. So that all of this information, let me play it actually, it is stored on the disk. So how else do we expect to browse the internet? You see this file over here? If I jump to, what is happening is that I get a folder with the temporary internet files, with this MP4 file over here, that I can obviously check out, and let me sort by the size maybe. And then this is something, this .dat file, you see, that is growing in size. Obviously, just because, as we see, it's still growing, yes, because I'm streaming this video underneath, in private mode. Obviously, if I close the browser, that particular file, yes, we can refresh that, is going to be deleted, this .dat file. But is it really deleted? If someone is about to recover data from the drive, that is clearly not in private mode. So, kind of my husband is busted. You know. Whenever we are thinking, of course, this is just a warming up demonstration, yes? Things in the operating system, they're always obviously stored on disk, and it's just a matter of question, how do we play that? Okay, guys, the next demonstration that I got for you, it's going to be actually pretty interesting, because what I would like to show you, it's within the console. Let's start it up. I'm going to just minimize it so that everybody can see it clearly, like this. And we're going to be playing with the chunks of the data that application. And on the H drive, I got the secret data, yes? This is just a folder. What we've got inside, I will show you this through GUI, yes? So data that application, I'm going to enter my secret data. There is the file, it's called AAA. And that is the place where the data, it's a disk where the data that application is turned on. And it just contains some information, yes? What is pretty interesting over here, that if, of course, we're gonna delete this data, yeah, so let me do that, from this particular volume. So we've got a DD application, these two folders, I'm just gonna purely delete that, continue, and then data is deleted, my secret data copy, perfect. I created the copy so that it gets deduplicated, yes? The application is the technology that saves us the space based on the chunk management. Good. So now question is, even though those files are deleted, is there any more information about the files themselves? Of course there is. What we're going to do, let's move to the folder. In this particular case, it's the system volume information, DD application, one more file, access is denied. Let me see why is that. Because of course, I need to elevate myself. Apologies for that. It is my mistake. So I'm going to go to the C, and then let me go to my tools, psexec -s -i -d cmd.exe. Perfect. We've got a console. We are back on track. Because it was the system volume information, we have to be a system for that. So we're going to go to H, and then we are all on track, system volume information. We're going to go to the DD application information. Yes, we've got here different kinds of folders all over that contain different kinds of chunks. In this particular case, very obvious, we're going to go to the chunk store. And then, next thing is that we've got a very special name of the folder, this kind of identifier. Let me enlarge the console, DDP. And then next folder that we've got, it's data. And we are pretty much there. We've got here 3 files. This CCC file is the one that is very interesting. Why is that? Because it contains all the chunks of the deleted data. So if you take that, you can find out over there the history of whatever was on the disk, even though it was deleted. So if I pretty much copy this particular data, and let me copy this CCC thing, and I'm going to copy this to C ignite. Very good. Yes, let me override it. Very good. Then the next thing, obviously, that I can do, let me move forward. I can open it in Notepad, but it will not be that cool. What we're going to use for that, in the C drive, I'm going to enter the tools, and I want to run on them strings. And I'm going to run strings -n 10, so that we've got, of course, a certain amount of characters being transmitted. It's a very nice tool to binary search for the different kinds of information, for example, in the memory, like display me all of the strings that are 10 characters long or more. So later on, of course, let me go to the ignite. One more time, ignite. And then I'm going to go to the CCC, and that is exactly what was on the disk. So all of the data that you think you deleted, obviously you didn't, yes? It's cached somewhere else. And just because we are managing the chunks, you are able to find the chunk data over here. What is the solution for that? Well, the solution is that within the data application volume, you need to run the garbage collector service. And that pretty much depends how frequently you're going to run it. If you're going to run it once a week, you're going to here have all the data that was deleted, and it's going to be maintained for the 1 week. You put the file that you didn't want to, okay? It's going to be there. So whenever you want to, of course, clean this information, this is to be mitigated, and the garbage collector service for data, the application volume, is going to work out over here. Very good. So whenever we are thinking about more solution, are we able really to just take the file out of the disk, so delete it and then recover it just like that without any problem? Of course, it's just a matter of appropriate tool. And it's always a matter of appropriate tool. So what I'm going to show you in this particular case, I got another volume. It's F. Let me clean out the screen. What we've got in this volume are 2 files, yes? 2 CMDs. That, of course, I mean, they've got just a very simple content, nothing really important, yes? So something, yes? Just to prove that we've got a file back, yes? So whenever we are thinking about how we are able to play with the deletion, encryption, and then recovery of the file, we will do something that is called an NTFS walk. So what I'm going to try is to recover the file just after, obviously, it was deleted. What then I'm going to do, I'm going to encrypt that chunk of this particular volume, and so the volume F, which is very small, and then I'm going to try to get it back too. And we're going to see what kind of result we've got. Okay, guys, so the first thing, what we need to do, I will pretty much open up the wipeit.cmd. Wipeit.cmd, what it does, let me show you, notepad, punk. It very much just deletes one file and that just deletes another file. This is just information for the software licensing that I got. So one file, another one, not a big deal. And later on, it encrypts it. Yes? So let's see what kind of stuff we can have. So this particular file was deleted. How do we know that? Well, as simple as this. If I go to that particular drive, I no longer see the first CMD, I see the only second one. Okay, guys, so what I'm going to do in the second console, and I'm going to run it simultaneously, is in the second console, I'm going to, on the same volume, run the recovery file. And that particular recovery, here we go, recovery.cmd, enter, uses the tool that it's called NTFS walk. It's a very useful tool, by the way. It's not a free tool, unfortunately, but it's not very expensive. I think right now it's about $150. It's a part of the very useful disk toolkit that is called TZWorks, and it allows us to recover data like this. So if you delete yourself a file by accident, you are very easily capable to recover it using the tools pretty much like this. Okay, so question is, do we really have this recovered? And on the desktop, I got the undelete folder where I can find information about this particular file. It's a bin file, where, as you see, the content is exactly the same. Yes? Next part of the presentation is that what I'm going to do in this particular case, I'm going to delete this file, and then I'm going to overwrite the drive with the encryption. So I'm going to use Cypher for that, and let's do that, Cypher/W on the F volume, and what it does, it encrypts me the whole volume. And perfect, so this is the whole thing. And what I'm going to do on the other side is the same story, yes? So in this particular case, I'm going to, again, fire up wipeit, and then the question is, sorry, not the wipeit, but recover, and then the question is, will we be able to recover it one more time? And obviously, let's see, something gets back. So big question is, why do we get the data back? Let me go to the desktop to show you in undelete that this is exactly what happened. So this is the second folder, as you see, deleted, none, cat all, and we've got these two files, yes, and this is the file you have been pwned again, whatever. So the question is, why are we able, after encrypting the disk like this, to get the data back? Isn't it the fantastic method to prevent getting the data back? Answer is yes. But in the NTFS, in the metadata of the files, there is a very special way of treating files that are smaller than 1.5 kilobyte to store them in the metadata fields instead of the data fields. Okay? So if you do have files like password and txt and you put your password over there and you encrypt your drive using at least this method, yes, then obviously this information is going to be still on the disk. Just a small eye-opener. So what else can we do? What kind of other stuff we've got? Well, of course, whenever we are thinking about, let me get to the machine, playing with the different kinds of files, let's bring this here. I got here the folder Ignite, and in this folder Ignite, I have copied two files, SUM and security. These are pretty much the registry hives. The question is, how have I done that? Because this is a small challenge. And answer is, it's actually very easy to do this, and again, we need to have an appropriate tools. You might be, yeah, it's not a big philosophy to copy that. Well, it actually is a philosophy, because if we're going to start, even though the console as administrator, I can do copy, and then a Windows System 32, so config, and then I'm going to specify, for example, system, because this is what is missing over here, and I want to put it in a C, Ignite, and that's it. It says that the process cannot access the file because it's being used by another process. Not a surprise, yeah? Non-for handle. So, okay, how am I able to copy this kind of file then? And he comes to the place, a very useful disk toolkit that is called TSK, or SlothKit. And what it gives us are the tools that are, instead of using this layer, the logical layer that allows us to access to the disk, it takes the file directly from the disk and it's presented to you from the physical device. And that's what we need. We need to copy the data stream out. Okay, guys, so what I'm going to do, I'm going to show you right now how we are able to copy the stuff that we're not capable to copy. Yes? And as you heard by my last presentation, just because of my Polish roots, yes, I'm very stubborn. Yes, it's another not very nice thing. But I'm very stubborn, like, what do you mean, excuse me? Like, I cannot copy my stuff? I paid for this operating system, yeah? I can. Like, just don't tell me this. Okay, so what we're going to do, as simple as this, let's go to the toolkit. And we've got our tools over here. Let's see. And TSK. Very good, CLS. And what we're going to do, we're going to use, at the very beginning, the one simple tool, which is, let me go to the binary, one more thing. Yes, here we go. One simple tool, which is called MMLS. Yes, they've got these beautiful names. I mean, it's completely not easy to remember all those. So write it down or just watch the video later. Yes. So we've got this MMLS.exe, and what we're going to specify is that we would like to run it on the physical and then drive 0 and physical. Yes, makes sense. So what it shows you, of course, it's the how does the drive looks like. And now, where does the data begin? Because a lot of things, it's a drive descriptor. So what we can take, what we see is that we've got this basic data partition, and that identifier, it's the place, it's the sector where the partition, the regular system partition starts. I'm going to copy that. The next part, it's very, very easy. We would like to, from this particular partition, copy the file that we were fighting for. So, system. How are we going to do that? Well, as simple as this, we're going to, at that particular case, and I'm sorry we had to do this, we had to write our own tool for that. And that tool, it's called CQ, because we've got a series of the CQ tools, TSK file info, that's going to show me something that, guys, Linux shows immediately. Why the Windows doesn't? But okay. Which is called inode. And inode is the identifier of the file on the drive. I need to be able to touch it to be able to copy the file out. So what is the inode of system? So we can check that out by specifying, of course, our tool, and then our tool takes us the parameter as simple as this, system32, not ini, but 32, here we go, config, and then I can specify system, and it of course gives me the inode. And the inode for that, it's 41902. So now I'm ready. What I'm going to do right now, I'm going to use another tool to be able to display myself information about the file on the disk. Why? Because I need to know where is its data, where is its descriptor, yes, because I need the data out. So, next stuff that I would like to do, as simple as this, let's go to bin, and I'm going to use another TSK tool. Everything is free, by the way. It's a very nice toolkit, and that's going to be the istat.exe, where I'm going to identify -o, the place where the data begins. So this is the start sector that we used previously within the is displaying information on the disk. And the next step that I'm going to do is to define, and again, physical device. Maybe I'm just going to copy this from here. It's going to be very comfortable. Here we go. Yes, from that device. And display me the information about the inode 19902 bank. And this is what the system is about. What else information, what kind of other information do we see? Well, we see, for example, let me maybe bring the buffer that's going to be bigger in this case, because, here we go, maybe a little bit bigger. Let me run it one more time so that we can fully see what was going on. So here, we can see, of course, the information about the file itself. Yes, it's a pretty long file, but the file, here we go, this is what I want to show you, has its own information. We've got the journal update sequence number, because in operating system, we've got the NTFS journal. Last year, I was playing with journal as well. And here we go, we've got the file name, some attribute values, and we've got the field that is called data, and that's what we care about. Okay, guys, so we've got 128-3. That is how the data is identified over here. So what we can do right now is to, simply speaking, use, and again, another tool, yes, to copy the whole data out. And instead of using istat, I'm going to use the icat. It's another tool, the same parameters, but one more thing, because as you remember, it was 128-3, I need to specify which stream I would like to get, and obviously, I need to specify where I would like to have it, and I would like to have it in system. Enter. What it creates me, it's the system file. Copy it. Question is it consistent? Because maybe I just took some data out and then it's going to not work, as simple as this. Well, let me show you maybe. In order to be able to extract the hashes from the operating system, you need 3 things. System hive, security hive, and, of course, SAM hive. SAM, system, and security. So to be able to do that, what I'm going to do, I'm going to use another tool. This is another tool that I'm going to share after the conference. We wrote it. The reason why we wrote it is because I get annoyed. And I was like, why the hell in this world? There is not a good tool that is working every single time I launch it when I want to extract hashes. Sometimes it crashes, sometimes it's recognized by antivirus, for example, which is also the disadvantage, yes, and so on. So what we did, we just wrote on our tool, and it's not recognized by antivirus, it never crashes, and it works very nicely. Okay, so what I'm going to do, as simple as this, so I'm going to extract, of course, the whole information, so sum dump, from the files that I have in this place. So in Ignite folder. So sum dump, and then I need to specify sum, where is it? And sum is in Ignite. I need to type it, it's not tabbing. So I just need to type the whole thing. And then I need to specify, of course, the sys and C Ignite system. And then I need to specify security. So C and Ignite security, yes? And then after enter, if all of the chunks are correct, you are able to extract the hashes from the operating system. That kind of proves that the method that I picked to be able to copy the files out, it's reliable. Some questions? Thanks. By the way, we are warming up, okay? I'm serious. So, next thing, the cached information, yes, that's what we are talking about. So, what I have over here is this small tool, it's called RDHash. RDHash, I mean, if you want to know the background story, I celebrate something that is called the name day. So when there is Paula's day, yes, it's pretty much in 1 month, and then my husband is like, hey, I love you, blah, 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 yeah, all this boring stuff. So pretty much, my husband, instead of giving me the flowers, he's doing the same things as I am doing. We're a little bit creepy, yes? So what he did, on one of the names day, he wrote me the tool, and this is this. Apparently he doesn't love me too much because the graphic sucks, but what can I say? I mean, I cannot complain on something that was given me for free and with the goodwill and a couple of other things, yeah? Okay, so the question is, of course, where do we see the information about the whole cache? Before we get to the place, what I want to show you is pretty much, of course, where we are able to search for the information regarding the user. So whenever we've got, for example, some kind of, let me see, am I good? Yes, I'm good. Whenever we've got, of course, users, and we've got Freddy, in the Freddy's app data, we can find here information about different kinds of cached data, yes? So we've got Microsoft, local law, and so on. We've got also roaming, Microsoft, and couple of other things. The question is, of course, where we are able to find the chunks like this. And in Microsoft Windows, we can, of course, find a lot of different files. What am I searching for? It's the very special type of cache. Let me show you. And that particular cache is pretty much related to the terminal services. And we can be able to find that information either in the registry, either in the certain types of files. So whenever, of course, we've got a cache on the disk regarding the data services, let me take this out, then we can find the information, of course, let me do that, what kind of connections, different kinds of connections, people were using. In this particular case, I pretty much don't see much, yes? But if it's about the cached data, the remote desktop connection stores that kind of information on the disk. And let me, of course, show you where that kind of information will be. So, I kind of, let me see, because my cache is not that clean right now. But, because I see right now that, let me see what happened with the cache itself. It should be in the user here. I mean, in worst case, I'm going to be back to this, but we don't see it. I mean, it should be within the local, and we've got the Microsoft, and then we should pretty much see it here. What happened to my cache? Yeah, let's see. we're gonna of course get that information out in a moment. And that cached data is something, of course, that presents us different kinds of pictures. Oh, my cache should be here. Let me see. Sorry about the confusion, but it should be there. In a worst case, I'm just going to copy my cache out, and then I'm going to connect to the cache that I've gathered. So let me do that. Okay, because it should be there. Let me paste it. I'm cache that I've got prepared. Yeah, it is, you know, but I don't see it, and that is the issue, yes? We can try one more time, but in the Freddy, and then in the app data, something got deleted in my cache. In the local, and then we should get the Microsoft, and then we've got, of course, the Windows folder, and then here we should have the services. Yeah, so something is not perfect. But regardless, of course, let me load that information from the cache that we already have on the desktop. Let me open the file, and let me try to decode it. And that's perfect. That's exactly what I want to show you. So, small recovery. Here we go. So, every time, remember that whenever you are using the remote desktop services, you connect from anywhere. You are caching in the user's profile the pictures of whatever you are connecting to. Yes? We could be like, yeah, but that sounds like bad party, yes? Wait a sec. I'm going to change the chunk size in the file, and let me decode it. And that looks a little bit better, I guess. So whenever you are on a vacation somewhere, browsing internet from the internet cafe, be aware that if you are checking your account status, if you can afford another cool ride with the helicopter or something like that, yes, people will see how much money you've got because the pictures is gonna be gathered. That's why RDP connection, by the way, it's so robust, because it caches the chunks of data, and whatever changes, it replaces the picture, and whatever doesn't, it doesn't. Very cool mechanism, by the way. What was that? Who said this? You said this, IIS? You want a sausage or a t-shirt? T-shirt? It's a Polish sausage. So, okay, you're gonna get both, okay? Yes, it's here. It's an IIS, we see that, yes? So what happened is that this person was actually browsing IIS. Very good. So next thing I wanted to show you regarding the whole caching, it's something that is called prefetch. And prefetch in the operating system is very nice because in prefetch we are able to see what kind of different applications were running in the operating system. Let me zoom it. And in this particular case, I'm using the tool for the prefetch that is in C Windows prefetch to analyze how many times different kinds of executables were running. By the way, I'm a huge fan of this. Sometimes we've got these different kinds of forums with the different tips and tricks. What kind of data should you remove from your drive so that you're going to save the space on the disk? And one of the things on the list is prefetch. Yes, you just save 10 megabytes, yes? So basically don't delete prefetch because it contains the information about all the different stuff that you had running on your drive. And what I'm going to do, well, first of all, just to see if it contains some files and what kind of files we are dealing with, you can see over here that these are different kinds of QMI, wget, WF parser, different tools that I was running on this particular box. But question is how much I was running those. So let's go and find out. And with the PF tool, and again, coming from the TZWorks and other tools, in the disk analysis it's very hard to get the good tools. So I'm trying to use as best as possible. TZWorks for that is actually good. So what you see over here, it's the analysis of the Mimikatz that it actually ran, as you see, 3 times, and you exactly know when. It's the history of whatever was executing. If you had the CryptoLocker, you're going to see in prefetch that executed at that time if you want to investigate back what happened with, obviously, your disk. Okay, guys, so this is obviously one of the things. Whenever we are thinking about different kinds of credentials and the credential history stored on the disk, again, another interesting place for caching. And that interesting place for caching, we've got, let me see, pretty much here. So this is my another machine. Let me clean the view, where I'm going to just start the command prompt. And I got over here another tool. It's credhist decrypt. It's the tool that is written by our developer because we could not, again, find a tool that's going to give us the information about history of the credentials stored in the operating system. And you will be like, is there one? Of course there is one. It's this credhist file that I was describing. What is this used for? If you're going to save the data from the browser, and it's going to be the password, this password needs to get encrypted. And one of the keys that is used for encryption of storage is your password. So if you pretty much get the new one, you need to still get access to the older encrypted data. And that's why credhist exists, to make these things possible. So what we're going to do here, I will specify, in this particular case, you need to specify your current password to get access to credhist, and then, of course, you need to specify the whole path. In our case, and it's everybody's case, it's app data, like this, data, here we go. And then we've got Microsoft, and then we've got protect, and then we've got credhist. And that shows us, in my case, I got one entry because I didn't change the password in this particular machine. If you change your password, you're going to have the whole list of those in the file. Where can we get this tool? You will be able to download it after the session in my tools area. Yes? What does it contain, though? It contains different kinds of information. In my case, the anti-hash, it's null. That's a special case. But in your solution, in your case, you're going to have here the anti-hash. So this is the hashed version of the password that pretty much you had before. Okay, guys. Next stuff. Next stuff is going to be touching the scenario that is related in operating system to something that is called, and that is the next stage, which is the system scenario, data protection API. Data protection API pretty much is within the computer. It has been improved from Windows Vista. For the data protection API, you are using asymmetric cryptography that is engaging your current password or effectively your current hash to be able to encrypt the data. It's used to encrypt a lot of different kinds of things, including, for example, passwords that you store from the browser and so on. Whenever we are thinking about the whole idea of the data protection API, it's really good. And even though there are two guys, Jean-Michel and Elie Boerstein, that claim that they broke it, it was never shown to the world how this is done. Though I kind of believe that bad things might happen. Yes? So this is really deep inside in the operating system, because what we are searching for is the vulnerability for the encryption mechanism and the methods how the keys are stored within the operating system. Okay, guys, so how does the whole story begin? Let me bring, of course, the virtual machine to the field, and let's analyze the whole situation. So first of all, what we will need in order to get access to the certain data is the scenario. And let me tell you what happened. Let me clean this out. There's a lot of things that we are doing, and I'm bringing the machine, this particular machine, back. Here we go. Yes. So this is the machine of Freddy. And what happened in our scenario, let me pretty much switch user and log on as Freddy. I'm going to do that. It's a Freddy Krueger account. I'm using it for the different kinds of accounts, presentations, and so on. So this particular Freddy he is still working. But the scenario is as follows. Are we able to get access to the user's secrets, like passwords for the browsers and so on, if we do not have any kind of recovery mechanism? For example, our account, it's no longer in the domain, because what we need, it's the, of course, user sid being in the domain and the password of the administrator to be able in order to recover it. So this is the thing. Next thing is, if the account is not in domain, then we don't have any kind of recovery possibility. What's more, even though we know the user's password, question is, what if the user, when it's, let's say, fired, dismissed, has some information that got encrypted, account was deleted from Active Directory, user, though it's so kind to give us the password, but how we are able to recover all those keys that took part in the encryption process. Let me show you everything, it's gonna be clear. So this particular Freddy guy, he's got Outlook, and he's got, of course, his data file, where he has some passwords. And I send him an email. Hi, Freddy. Yes, these are the passwords. As you see, this email is encrypted by the padlock. So question is, if we do have access physical to the machine, are we able to decrypt the message like this? So what I'm going to do, let's have a small look. So right now, so I'm going to just log off this guy. It's, right now, from our perspective, it's just the offline access. And the administrator comes in and he's like, let's, one more time. Let's have a look at the Freddy's computer. And let's have a look at his profile files, what kind of stuff we are able to read. So the first thing we're going to do, if we would like to get access to this email, we're going to find where is the drive where Freddy was getting his mail. Where is the PST file? So if you've got OST, you've got a lot of different kinds of OST to PST converter. It doesn't really make a difference here. So what I'm going to do, I'm going to go to the, well, Freddy's area. And in the, let me see, particularly Freddy's documents. So, well, not this one. Here you go, my documents. We're going to have, of course, some information regarding the Outlook files. So there is this Freddy's PST. I'm going to copy this to myself somewhere in the temp, maybe. Here we go. And I'm going to paste it pretty much here. This one I will delete. I was just checking out for sure if everything is working. So we've got this Freddy's archive. What I can do, I can pretty much take the whole, just delete it so that everything is clean, Outlook file, and I can, of course, add it in Outlook just like it is. So I can open it, and this is the Freddy's Outlook file. So I'm going to go to the place where I saved it, and I saved it in the temp file, Outlook PST. That's the Freddy's Outlook. Good. So I got this Outlook data file over here, yes? And I can find out, where is this? Is this the one that I wanted? Let me see. Is it for sure the one? Just to double check. Freddy Outlook files, my documents, that should be pretty much the one, yes? But when I'm opening it, maybe I just opened the wrong one, yes? Let me have a look one more time. Sorry about that, because this is not the result that I want. Okay, so what I want is to go to the temp, yes, and I want this file to be loaded, Outlook data file. But it's kind of, let me see. If we do have all the information, wow, one more time. Oh my, let's see. So we've got Freddy's profile, and then in his documents, we should be able to get that information. So that was where Freddy had his PST, or in worst case, we can check that, but that was in the Outlook files. Or let's go to the profile itself. Oh, that is actually pretty confusing, yeah? Because he had that information over here. It's not in the desktop. No, in my case, it will not be, you know. It's a good suggestion, but in my case, it will not be in app data. Oh, okay. So let's do type PST, as simple as this, yes? We should be able to get his file. Because this is the only thing that we've got, yes? And that should be something else. Yeah, let me see, double check. Sorry about that. I just want to show everything step by step. So I'm going to log the desktop and log on back. Switch user. Log on back as Freddy again, and I'm going to pretty much see where is that, yes? Because it's supposed to be where I'm saying, yes? Let's see. And that particular data, we're going to, of course, work on, and we're going to extract the information out of that. And we're going to see, come on, Freddy. And we're going to see, of course, if it's possible to recover his information or not. Ah, there is a typo. Here we go. Password. In the worst case, I get a backup archive that I can use that was used like this. Okay, very good. And what I'm talking about is this archive over here. Yes, data file properties. And then we can see, not the folder size, but advanced. Where is this? Oh, okay, C tools over there. Sorry. Yes, here we go. So what I'm going to do, I'm going to connect to the same file as an administrator. So let me log off. And then I'm going to see if I'm able, obviously, to get access to this email. And I shouldn't be, because it's a data that was encrypted. So let's go to the tools. And here we go. This is the Freddy's archive. Control C. And I'm going to put it again in temp. Control V. We shouldn't be, because that is the information that was encrypted by the Freddy's, of course, RSA keys. So what I'm going to go, let's do this and let's open the file one more time. And that's going to be in temp this time. C, temp, and we've got the Freddy's archive, very good. And then we are on the track, perfect passwords, and then obviously I cannot. Okay guys, so here comes the party. Because what I need to do is to work on the Freddy's message and try to find if there is any way in the disk to get access to Freddy's certificate to reconstruct the PFX file and then be able to move forward. So let's see if we're able to work on that. So I got this message. I'm going to get this message and I'm going to put it in temp. We're going to work on that. And for that particular case, we've got different kinds of tools that are written to be able to recover data from the disk. One of the tools that we wrote, it's called MSG decode. So let me start the console and let me enlarge it a little bit. Here we go. And let's start working on this message. So first thing that I'm going to do is to go to the tools where I've got my message within the email tools, where I've got my message, here we go, decode. Message decode takes pretty much as the parameter the message that we have downloaded. So message decode will identify me in temp. Here we go. This is this file so that we want. What kind of certificates are used? And what we see over here is identifier of the certificate of the user. So question is, can we take the certificate identifier and map it to something that we've got running within the operating system? Because this is the Freddy's machine. Answer is yes, we can. How do we do that? So let's take this identifier, and I'm going to use another tool, which is actually very easy. It's called findBin. And findBin, it's binary searching for the string within, and I will specify, of course, the folder. And that's going to be the folder where Freddy has certificates. So in our case, it's going to be C, Freddy, C users, Freddy Krueger. Let's see, C users. Let me see. Let me just copy the path. It's going to be so much faster. So C users, we've got Freddy, and then we're going to go pretty much to the Freddy's app data, roaming, Microsoft System Certificates, my certificates, and this is, I'm going to shift click and then copy the whole scenario. So I'm going to do this, copy as path, and then I'm going to pretty much paste it over here, paste. So then the result shows me clearly that there is some certificate in the container. Question is, are we able to recover it? And here comes the whole magic. And the whole magic is like this. To be able to recover the user's certificates, we need to get access to the user's, well, at some point, so-called master keys. The user's master keys that are used to encrypt the private keys that are on the disk are in the following folder. So what I'm going to do first, I'm going to copy this body, and I'm going to start collecting data. So I got email at work, I'm going to paste it here, and I'm going to create new folders here. One folder, it's called in, another folder, new folder, it's called out. So I would say the master keys that are maintained by the user are in app data, roaming, Microsoft, protect, and this is the place where we store them. Yes? This is also the place in the protect when you've got the cred hist. So what I'm going to do, I'm going to take the whole thing, the whole protect copy, and I'm going to paste it in the data gathering folder. So email at work, in, paste. The user's private key that is necessary to get access to the user's data, it is available in a pretty much similar place. Roaming, Microsoft, then we've got, of course, crypto, and then we've got RSA. So what I'm going to do, and what you see over here, is this is particularly the user's RSA key. So what I need to copy, of course, all the information out right now. Okay, so we are pretty much good to go. And that particular RSA stuff, so I'm going to copy this, I'm going to copy to the folder that we are working on in. I'm going to name it new folder RSA, and this is where I'm going to put the user's private key that is encrypted with the master key, and I need to get this key in order to build the certificate that's going to allow me to get access to email. Make sense? Good. You're with me? Very good. So, next stage is obviously the decryption of the RSA key. And so that we are able to do that, we need to use another tool. And another tool, it's actually based on whatever was existing on the market. It's the crypto, it's the certs. The tool certs, it's the one that you can compile using the different kinds of Python scripts. And that is publicly available tool. Though we have our own variants, which I'm happy to share, but you can find it without any problems in the internet. Good. So we've got our certs. And in order to play with the certs, we need to specify one more thing that is missing over here. And that is, at that particular point, the user's seed. So I'm going to go to Freddy, app data, roaming, Microsoft, protect, and this is where the user seed is. F2, Control C, and we've got the user seed. So we specify, of course, the seed. Here we go. Paste, we got it. Next parameter, we need to specify where are the master keys to decrypt the RSA keys. And master keys are in the C, email at work, in, and then our master keys were, at that particular case, in the protect folder. Next thing we need to specify is RSA keys, the one that we're going to use them for the decryption. So they are at email at work, in, and in RSA. Next thing that we need to specify is the user's hash. If you got a backup of the ntds.dit, you are able to extract the information like this. So either user gives you the password because user is nice, or you recover the user's hash from the ntds.dit from the backup of the Active Directory. I was showing how to do this on the last session. This is pretty easy to follow. I'm going to simplify this demonstration, and in this case, I'm going to give the password. I can also specify hash. There are two options that work. Password, and I'm going to specify the password. So everything looks fine. Enter. Let's see what kind of stuff it's not there in place. Master key, email protect. Let's see. Let me see exactly what is the issue. So we've got the Freddy. Let me see what kind of information I've got here. That is the email at work. We've got in, protect. There is only one key. This is fine. This is exactly what we need, and we need the correct keys. RSA, we need a key like this. That's for sure. Aha, one more thing. I'm sorry. I need to specify the out dir. Yes? Of course, I'm so fascinated about this decryption thing that I don't care about the result. Yes? Out dir. Ta-da. C, email at work. And then I need to specify the out. And that's pretty much it. And then password. And then we can specify the password. Very good. Bang. Decrypting. Let's see where we're going to end up with this. Lovely. You see the private key? Yes? Okay. So, smoke a cigarette. Let's move forward. Yeah? The next thing that we need to have is to regenerate the PFX. And in order to do that, we need to obviously use the file that we've got, and this particular result. So when we go to out, that is where we've got our private key. How does it look like? Simple, yes? So in order to regenerate the PFX file, we're going to use the tool, and again, that we had to write. It's a new research done, and as far as I know, people were not touching this before because we could not communicate with anyone doing this. So I'm going to jump to the PFX regenerator, and PFX regenerator is going to show me, first of all, PFX regenerator, it's going to take as a parameter the key that is already stored in our case, email at work, and then out. And this is the key that I'm going to use. So I need to regenerate the certificate, and I'm going to regenerate it with this file. I'm going to specify it out and specify recovered. So let's say C, email at work, out, recovered PFX, for example. And next thing that I need to give over here is the in, which is the name. This is the public key that was available within the system certificates, and that is the one that I copied over here, yes? So in and C, email at work, and then I need to specify this long guy over here, yes? At the end, let's see what is, we've got the in, we've got this, we've got, oh, there is a typo. Is it out? Let's see, PFX regenerator. Yes, there is. At the very beginning, we need to specify the in value, and that is over here, in, and then we're pretty much good to go. No, not yet. In key, yes. Okay, got it. Thank you. Michael, our developer, is not always user-friendly. In key, that's perfect. Successfully recovered, yes? So now, we've got this message that we could not recover it, yes? If we go and, at this particular case, recovered, import our certificate, we are setting up over here the password secure. C-Q-U-R-E, yes? Next, finish, great. Email, bank, small refresh of the message, passwords are recovered. You know what? That's not everything. One more thing. It's a cherry on the dessert, yes? What I wanted to show you is the situation. So this is purely data protection API and the data recovery. What I want to show you is that are we able to play with the cached credentials of the users in the workstations? So what I want to show you first is that I'm going to log on as Freddy and password. It's going to be shorter one, by the way. Yes, I want to sign in anyway. It's the Hyper-V thing. Sometimes it happens like this. Okay, so there is Freddy's desktop. Yes, the scenario is as follows: Freddy's laptop got stolen. Question is, what kind of secrets people can get access to? And it's not just unlimited, because it's a pretty hard subject. They can become administrators, yes, if the laptop is not encrypted, but if the disk is not encrypted. But if you reset the password illegally, not as a user itself, not as an admin of the domain, the data protection API gets blocked. You will never be able to get access to it again. So let me show you something cool. So in this particular user, I've got in the user's documents the important data that is encrypted. It's green, but user has the key to it, so user can get access to it. Next thing that I want to show you is that in the tools, I got the Chrome Pass. It's the tool that is by Nearsoft that shows me what is the user's password that is saved through the browser. It's normal, yes? It's the data protection API that pretty much maintains that. If I will not know the user's password, I will not be able, in general, to get access to the information like this. So, the big question of the universe, and of course the same story applies to an email, is that can I get access to an information like this? Email is one of the stories, by Freddy. And answer is, of course, I can. What I'm going to do, I'm going to sign Freddy out, and I'm going to log on as a local administrator in order to show you that I am not able to get access to the Freddy's data yet. So let me, of course, do one thing. I'm going to go to the same tools as Freddy did. Yes, so let's go to the tools, and let's go to the Chrome Pass. And when it opens, it takes a small moment. We're going to see, of course, if we get access to all of the passwords in this computer. In the meantime, when it opens, I'm going to go to the same place as we were with Freddy. So users, and then Freddy. Continue. Oh, I'm going to just run that. Okay, as you see, Chrome Pass is empty. Yes? And in this case, with user, I'm going to continue because I'm the local admin, I can do that. And I'm going to go to the user's documents where he has this important data, password, access is denied. Not a surprise. Okay, until one beautiful moment. What I'm going to do is I'm going to load and boot up this machine from the Windows 8.1 to simulate the theft of the laptop, which means the only thing I've got here is the offline access. So let me restart this machine from the ISO image, and let me proceed and move forward with the whole demonstration. What is pretty interesting is that this data that we were able to see as Freddy and we're not able to see as administrator is protected using the data protection API. This situation will not be possible, I have to say it, if user had an encrypted laptop. Because with BitLocker, I will not be able to get access to any information like this. Where can I get the user's password/hash from? And that is another question. I can get it if user is using the hibernation file. I can get it from the hyberfill.sys. If you were on my memory session, I was mentioning the tools by Matthew Seuss to manage the memory. One of the tools, it was called Dumpit. But what I used this time, because I took the hibernation file, I converted the hibernation file to DMP. And hibernation file, yes, it contains all of the user's informations. This is the Windows debugger. I've opened the dump. It takes a while, that's why I have it ready. I opened the dump within the debugger, and what I'm going to do right now, I'm going to load the library of Mimikatz, load mimilib, and then I'm going to run !mimikatz to be able to see the eventual user's credentials. But Windows 8.1 actually prevents users' credentials, but it does not prevent the user's hashes. So what we are able to see in the hyberfill file like this It's the user's hash. That's more than enough to get access to all of his secrets. So what I'm going to do next, repair your computer, definitely we're going to repair that, troubleshoot, advanced options, command prompt, and let me simulate the thefts again by disconnecting the network. Because what I want to do and what I want to show you, it's the completely new Premier thing, how to log on to the operating system using the cached credentials. So let's make it pretty, at least, yes? Unfortunately, I cannot change it before because it's the Windows PE. So I need to find the place where my data is, and it's pretty much here. I'm going to go to Tools, and in Tools, I'm going to go to the Kiwi Secure Edition, which is the absolute world premiere of the Mimikatz, since we are cooperating a little bit and contributing the Mimikatz with Benjamin. Benjamin is an absolute genius in this. We've got here our version of Mimikatz that is issued today. It's the first time this is presented. And hopefully it's going to work though, yes? You never know. I'm going to start, of course, Mimikatz, where I'm going to overwrite cached credentials. So how that's going to happen? Well, in this particular case, what I need to do is to do LSA dump and then cache, and then I need to specify the places where we've got the system hive and the security hive available on the disk. So this is Windows, I have to type that system32, config, and then we've got system, and then we need to specify, oh no, sorry, it's going to be system, okay, and then we are Windows, system, Windows, system32, no tabbing unfortunately, config, and then security. And then Kiwi, what it does, it patches all of the cache credentials with, perfect, the Mimikatz password. And the whole concept is, I mean, this is our edition. You're going to pretty much find it, as I said, today. So what it did, I patched the cached credentials. What is the next stage? Well, as simple as this. I can just continue and try to log on with the Mimikatz credentials. The next stage is going to be to get access to the Freddy's passwords. So we are rebooting right now, and what I'm going to do is I'm going to, at that particular stage, pick Freddy, and I'm going to type Mimikatz, as you see. That is the password that I'm using right now, and let's see if that's going to work out. It did. Yes? Let's move forward. We've got the Freddy's console, yes? Properties, and then, of course, let me change it one more time. Here we go. So, right now we have stolen the Freddy's session. Question is, what about this data? What about these passwords, yes? Okay, if I did it like this, the question is, of course, let's see if I am able to get access to his documents. If we go to the documents, important data, I still don't have a key. Okay, that's not a problem, since we've got a hash. And what I would like to show you is at that stage, I'm going to go to the disk tools. We wrote another tool, master key encrypt, to be able to encrypt the, in this case, private key of Freddy. So that we've got the master key that is also encrypted, and we need to decrypt it, encrypt it with our current password, yes, and then we'll be able to get access to all of the Freddy's secret. How does it work? Well, as simple as this. Master key encrypt. We need to use as well Windows, users. And then we go to the Freddy's information, Microsoft, protect, This is the Freddy seed, yes? So, and again, F2, Control C, I'm going to copy it from there. It's the most convenient way. So, I need to, of course, specify the Freddy seed, paste, very good. And then I need to specify the old hash. So, this is the one that we managed to take from the hyperfill. If it's there, I need to be fair. If it wasn't there, we will not be able to get access to the data. Cache credentials, of course, that is independent, but this is all about secrets. So what I'm going to do, I'm going to copy this, and I'm going to paste this old hash here, yes? And then, next stuff that we need to do is to specify, of course, the file where we've got our master key. And our master key that we need to pretty much get access to, it's specified like this, file, and then I need to give this full path to this master key, shift, copy as path over here. So I'm going to do that because we are decrypting it with the old credentials and encrypting it with the new credentials. And then, last thing, I need to specify the new hash. How I'm going to calculate that? Where, as simple as this, yes? Let me show you. In the tools, yes, or maybe disk tools, we've got a tool, small one, and again, written by us. I'm sorry about that. It's just not enough tools in the world. But I'm sharing all of them, where we are able to, let me paste the path, CQ hash calc, generate the hash of the user. So as you see, I got an option to define CQ hash calc, so let's do that. And then we've got the password, so I want to use, for example, password right now. And then I'm going to, of course, use the user. This old hash that we are using over here, let me see, in this particular case, so apologies, that needs to be, of course, the old hash, my mistake. Here we go. This old hash, this is not this value that comes here. What comes here is the current, the old hash, and the new hash is the one, yes? So the new hash I need to put over here. Sorry about the confusion. New hash is the one that we want to generate. So let's do that. Let's take it again from the file, paste works, and the old hash we need to calculate based on the current password. So mimikatz, and then we need to specify F. Krueger as the name. And here, what we see is the hash of the user calculated. This is the 60. I'm going to take this piece of string, and I'm going to pretty much paste it in the value of the old hash paste over here. We are all pretty much good to go. Very good. So what was created right now is the decrypted master key of Freddy that I need to replace, and this is the last step. If everything went well, we will be able to get access to the Freddy secret. Perfect. This is the one that was not working for us because it did not allow us to get access to data. What I'm going to do, I'm going to rename it .old, yes, and the modified, I'm going to rename to the one that's going to be working right now. And next stage is to give it an attributes. So shift, one more time, and then copy as path. And I'm going to simply speaking use attrib, paste, and I'm going to give it a system and hide hidden flag bank. Now we're home. So question is, can we get access to the Freddy's data? And let's see what he has in this document. Remember, after logging on, I wasn't able to open his files. Oh, let's see. Still access is denied. That's actually interesting. Let's see, why is that? We've got the file that is created over here. That's pretty interesting. Let's see how does it work for tools, because maybe we'll be able to get access here, yes? Let's see. Something did not go properly. We've got the seed, we've got the old hash file where we are specifying the key, new hash, and then we are specifying the new hash. Oh, my mistake. Uh-oh. One more time. The old hash, I did it in the opposite way. That's not a big deal. We're going to correct that, yes? What we're going to do, let's see, let's go back. I just replaced the keys. That is what happened. Let's have a look. Roaming Microsoft. One more time, protect. These keys. The old one we're going to leave. So this one we're going to change again to the XXX. Yes? The old one we're going to bring back. And attributes, one more time, typo. And that's going to, that should be working right now. I see the issue. So we've got this key over here. And this particular key needs to, let's, of course, add it an attribute. It has the same name. So it's all good right now. And then one more time, yes? The final time. So the old hash is going to be the one as I give. Paula, this is the blonde thing, you know? I'm never forgiving myself. Okay, so the old hash. That is the one that was from the Kretgist, from the Hyberville, and then the new one, sorry for the trouble, bank comes in here, and then we are specifying the new hash. Oi, oi. Let's delete it, yeah? The new hash finishes with 42. So that is the one. At the end, new hash paste, and then let's see. Now we got it, yes? Now we need to swap the keys one more time. So that is the one that was used. Modified is the one that's supposed to work if we didn't mess up too much. .old. So then modified, then let's change it to the working one, and let's, of course, change the attributes. And at that certain stage, let's see, hopefully everything is going to be okay, if we are able to get access to the data. Cool. So, who wants a cigarette? Okay, guys. So, small conclusions. Time for the conclusions, yes? Data protection API, as you see, it's actually pretty secure. Whenever it's about what we've been working on, if you are interested, yes, how does data blob decryption work on and so on, this key, this thing on the left, this is how the encrypted cache credential looks like, yes? And it has obviously different kinds of fields that you need to work on in order to decrypt it. The function, it's known. The function that is used, it's the PBK DF2. Yes, and if you work on the implementation by Microsoft on that, you are able to decrypt the cache credentials. Thanks to Mimikatz, we were able to decrypt the cache credentials, create our own, encrypt them, save them in the registry, so that the system thinks it's okay. Yes? Next stage was the data protection API, but as you see, this is a pretty challenging thing, because it required the users some kind of credentials, and for now, it's like this. What we did, we used the hash of the user's password from the Kretgist file. Whenever we are thinking, of course, about the whole session summary, as you see, in operating system, we do have a different kinds of places where we store all this information. A lot of things are encrypted. There is a lot of research still to be done. But, as you've noticed, there is a bunch of places that can reveal us any information. And just because it was a purely knowledge-related session, hopefully you became familiar with all those places. And next time you're going to put your data somewhere, you're going to double think, double check if, obviously, there is not too much that is revealed at the end. So this is the summary of my presentation. Hopefully you like it. And please fill up the evaluations. And hopefully see you next year. Hopefully you will have a safe travels home. And thank you so much, guys.